Hi, hello, uh, hello to everybody. I hope everybody is fine. And today I'll be speaking about the curiosity, and I hope you find the information uh, that's quite instigating, the information that's quite stimulating our minds, so that we may have more uh, uh, we may have more inclination towards the science. And and what I believe is that it is it is the momentum of the science that leads a state, that leads a country towards the prosperity, that leads the state or the country towards a complete development, the overall development of the social structure. So, what is the title is basically from curiosity to revolution, and I'll be talking about the three simple stories. The stories they are basically which has led us to the scientific discoveries, and these scientific discoveries have really changed the course of our life. They have changed the domain, the pathways of our life from some lower state to some higher energy state. So certainly the point is that the core intuition to talk about these well-known stories is to generate, it's to create the curiosity among the students, so that they can be more scientific in their lives. They'll choose science as their basic motivation to move on the society that they are living in. So these stories are very established stories of science, but I would like to reckon them that these stories, these scientific discoveries, have certainly led us to the revolution. And the core idea of all these scientific discoveries was the curiosity. It was the click. It was just focusing an event that has led to these comprehensive scientific discoveries, which have changed the course of societies in the long run. So, to introduce you with, science often begins with noticing. Science is not about that you have something in your mind, and you are trying to search something in the same framework. No, that's not the case. When you have something in your mind which you feel that you're going to get out of, it certainly takes you to something that is not quite developmental, that's not quite right about the nature of the reality. So, what it begins with noticing. There are many things happening in this room. The point is that, do you notice the right click? Do you notice the right event? Now, if you notice the right thing, that noticing is basically the result of that curiosity. Curiosity doesn't mean that you know and you want to investigate it. The curiosity is when you are in the framework of questions. You have a number of questions, and at the same time, you are curious, and you are focusing an event which is not focused by the millions around. So that's what makes your argument, that's what makes your noticing of the problem a basis of revolution, a basis of trying to know something about which you know nothing. So something strange is happening, and 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 you refuse to let it go. It is happening in front of you. Now, whether it's a famous story of falling apple, a moldy plate, linked with the penicillin that was discovered to save the millions of lives in those times when there was having no cure for bacterial infections, or a mysterious pulse. And this pulse, you are recording a pulse, and if you take it in a usual way, this pulse can be treated as an error of the measurement, as an error that's coming to your experiment, and leading us to discover something extraordinary, and becoming the laboratory of investigating the truthfulness of the Einstein's equations, the neutron stars. So the key is to ask, in all these three stories, in all these three arguments that we have been playing out here, what we have is why. Why something is happening. So the key is to ask why. And once you ask a question, once you come up with the right question at the right time, then you start to be persistent on that question. That will certainly not solve the problem. It's not like that you ask a question and you know everything about the nature of reality. No. Asking a question will take you to the next level. And maybe finding an answer to your question will open another framework of questions. This is how science works. Taking the example of Newton and the famous story that's always linked with, maybe this is not the true story, but it works to basically institute that state of mind in a person where you can develop that curiosity, that click. So what's that? In 1660s, what's happening? Isaac saw an apple fall from a tree. There would have been the millions of people seeing around that the apples are falling. The point is, most of the people ignore such events. But Newton asked, what he asked, if the apple falls to the ground, then why does the moon not fall to the ground? So the question is arising. It's the right question at the right time. The same event is observed by many people surrounding the planet. But the right question asked by this man, why the moon does not fall. And he comes up with an argument. And he comes up with the answer to this question. In both the cases, the apple is falling, nothing wrong with it. The moon is also falling. Okay? So this is the argument of the brilliant man. So the Newton question connected everyday events in the cosmic phenomenon. What was that? His curiosity led the law of universal gravitation, explaining both falling apples and planetary orbiters. So coming up with the equation, the universal law of gravitation, that gives us the measurement of the force of attraction between the two bodies having mass. If this force is equal to the product of their masses, it's inversely proportional to the separation of the distances between the two. Now this is an answer to the question that comes to his mind. He picks the right problem and looks for the right solution of his problem. So this discovery became the foundation of the classical physics. The whole of the classical physics has the basic bone. The basic bone of the classical physics is the discovery of universal law of gravitation. And this has changed our understanding of the universe forever. Now think about the projectile motion. The rockets that we launch so that they can land somewhere on the moon, the motion of the rockets is guided by the projectile motion that we study in 11th and 12th classes. It's used now. Our rockets are guided by those equations. And see the beauty of the result that's obtained by the right question. The next person is the Fleming. So what we call Fleming and accidental mold. You're creating a mold. And what is creating a mold, then when he accidentally looks the mold again after a period of time, he finds that the bacteria that is surrounding the mold, they're killed. And this mold happens to be a mold of penicillin, the penicillin. And looking at the mold takes him to the right answer. He finds a solution to a problem of which there is no solution throughout the land. And he's able to save the lives of millions of the people who could have died due to the bacterial infections. A small injury can lead us to have a bacterial infection, and this infection can reach out to all corners of our body and taking us to death. But this man's curiosity has brought the revolution in the life of the mankind. Not only the life of the mankind, to the life of the animalistic life that's living on the planet. You could not only save the life of the humans, you could save the life of the animals as well. So in 1928, Alexander Fleming left unwashed some Petri dishes while on vacation. When he returned back, he noticed the mold-killing surrounding bacteria. So instead of discarding, so what will an ordinary person like us, like me, what I'll do? I'll have a mold, I'll find it rotten. The best thing I can do is to take it out and let it down, let it fall down, and get rid of it. But this man is not doing it. He is not discarding it. What he's doing, instead of discarding this contaminated dish, Fleming studied the mold. He investigated, tried to investigate. What he did, he discovered it produced a substance that killed the harmful bacteria. So this mold was that gave birth to the penicillin, and this penicillin has its mark in the world history, where it has saved millions of people from bacterial infections, from the spreading of bacterial infections. So it has led to the penicillin revolution. This discovery, named penicillin, became the first widely used antibiotic. It has saved millions of lives and has revolutionized the field of medicine. The bell burner and the strange signal, as I said in the beginning of this presentation, in 1967, Jocelyn Bell Burnell detected some unusual pulses coming from the osmos and coming from the cosmos in radio telescope data. She and her team jokingly called it a signal from a little green man. They abbreviated it as LGM. The point is, the pulses they were continuously receiving from the cosmos, they were acting as an error to the experiment they were performing on. But again, see the curiosity. The curiosity of the person is taking the idea to revolutionize the knowledge to revolutionize the understanding of the cosmos. So what is it? Now, rather than dismissing the signal, so what will an ordinary person like us do? If we will find something flickering happening in our instruments, performing, having a target in mind that I have to get a sketch like this while performing an experiment. Now, anything that disturbs the result that I am interested to obtain in the laboratory, I will avoid, I will take it as an error and I will repeat my experiment. Maybe I'll say something has gone wrong with the experiment that I'm trying to perform. Now, what is happening here? They are doing an experiment in which they are expecting some of the results, and some disturbing pulses are coming in their results. Now, instead of filtering out these pulses from the data they are interested in, they are focusing on these pulses. They feel a curiosity towards trying to understand why these pulses are coming in the data that they are looking for. So rather than dismissing the signal, Bell Burnell investigated further. She discovered the first pulsar, a rapidly rotating neutron star. A rapidly rotating neutron star in the cosmos, emitting those pulses. She was receiving the radiation, the pulses were coming from these pulsars. And certainly revolutionizing the scientific world on discovering the objects in the universe, confirming the theoretical predictions of Albert Einstein. So these pulsars, they transformed the field of astrophysics. The pulsar discovered, reshaped our understanding of the stellar life cycles and extreme cosmic objects that exist in the observable universe. So, the moral of the story, it's the same kind of story that we have in our living bed, and we finally try to come up with a moral. So what's the moral of the story? The scientific breakthroughs often start with the curiosity. It's your curiosity that will take you to an unbelievable scientific discovery. The willingness to investigate the unusual. So when you have the willingness to investigate something that's very disturbing, something that's very unusual, that's not symmetric, that's not something that's widely acceptable. Now, if you question that, you must have a willingness to investigate that unusual. And what does that do? The unusual that you investigate, it leads to revolutionary discoveries, as you saw in these three examples. So in all the three stories that I tried to share with you, you'll find a common thread. There's a common rope in all these stories. What is that? You are noticing something unexpected. So when something unexpected happens, you have to notice it. And it certainly happens 1 in 100, 1 in 1,000 will notice it. The event is happening everywhere, but you will find that only one who notices will make the difference. And once you notice something unusual is happening, you will ask the right question at that time. So noticing is the right thing, but at the same time, you should be capable of asking the right question. And at the same time, you have to refuse to give up and give up on an investigation. So you cannot refuse it. You don't have to refuse it. You have to go on investigating with the right question what unusual you have noticed. So to conclude, from Newton's apple to the Bell Burnell's pulsar, these examples basically show that science is a journey. It's a journey from curiosity. And once there is curiosity, this curiosity will take you to revolutionize the society. So every nation must have the pupil. They must have curiosity. They should come up with the right questions. And once they have right questions, they can revolutionize the whole society. So with this, I would like to say you goodbye and have a nice time.